So let's go ahead and have a look at readers to start off. I'll go ahead and send you the link to the first lesson today. A lot of the tips we'll go over today are also covered in our knowledge base. If you're not familiar with it, the knowledge base is basically the largest compendium of information about using FME outside of the documentation. Documentation tells you kind of very explicitly what each thing does, but it doesn't always give examples or walkthroughs and things like that. The Academy is great for learning the basics of FME, best practices, and information that pretty much every FME user should know. The knowledge base gets a little bit more specific and focuses on using different formats, different transformers, and in some cases gets really into the weeds and things like known issues or more esoteric topics. And to some degree, performance, it's not an esoteric topic, but it isn't, the most important thing for all users. And so there's a lot of little details connected in that, or provided in that knowledge base article. So it is worth checking out. It does go into a little bit more detail on some topics than we'll do today, but we'll give you kind of the highlights during the training today. So how do you improve the performance of your reader? The main thing is to limit the amount of data that you're reading. We already went over that a little bit yesterday. You want to basically reduce the total amount of data that's coming in, and you also want to reduce the data throughout your workspace that you don't need. One thing to note is that reading can have an outsized impact on your workspace performance because once that data is read in, unless you're going to be removing it quite quickly, it has a tendency to sort of stick around. Now, of course, in some cases, that's fine. You're reading data in that you're planning to write out or use, but you want to basically reduce reading as much data as you can. If you don't need it, definitely don't read it in because it can kind of have a tendency to stick around and slow your workspace down. And of course, with performance in mind for production workspaces, you want to reduce the amount of data you're reading, but this actually also applies for authoring as well, which is if you have feature caching on, that does slow down your workspace and it slows it down proportionally to the amount of data you have. So if you're trying to author quickly, it's also in your best interests to have less data in your workspace and so you don't have to cache as much. And we'll talk a bit more about kind of differences with authoring approaches as well today. So the first topic, which we mentioned a bit yesterday, is making sure that you filter your input. And ideally, you filter your input before you read the data into your workspace. We went over this same example yesterday in terms of this is not really the ideal way to do things, to read everything in and then filter. It's really better to try to filter on read if you can. If you don't care about performance, this is fine. It's quite simple, but it will slow things down because like we talked about yesterday here, we're only actually using 419 out of the 13,500 features that we're reading in. Some of the parameters to check out to limit the amount of data you read are under the features to read section of your reader parameters, which is accessible in the navigator. And of course, is also accessible when you're adding a reader. See, there are some handy settings here, such as max features to read per feature type, and feature types to read. All three of those can be used to limit how much data you're reading. Now, of course, generally in a production workspace, you're probably not going to set max features to read or max features to read per feature type because it's assumed you're probably working with all your data. Though there are some cases where you might want to set that even in a production workspace. Maybe if you're just getting the schema, if you just need a single schema feature, for example, and you want to handle that with a reader, there's other ways to do it, which we talk about in part 2 of this course. But if you want to just get a single feature and grab the schema from it, or use it as kind of an example feature for some reason, you could just set this to 1. But more commonly, what you might see is people use that as a way to run their workspace when they're authoring and just limit, basically get a sample a bias sample since it's the first n features, but you could just set that to like max features to read per feature type, 100, and author your workspace with that small example data set, and then turn that off or increase it, make sure your workspace still works on a larger sample, and then see if it works on the entire data set. That can actually make your authoring process a bit faster because your workspace will just run a lot quicker. Another way to limit the data you read is with a search envelope, a bounding box you can impose, a spatial bounding box you can impose on the data as it's read. As we went over yesterday, it might seem slightly counterintuitive, but FME doesn't have to do all of the work to read the data in to limit geographically which data is read. And so adding a search envelope can decrease, I should say, the speed. No, sorry, decrease the time, increase the speed of reading your data. It is slightly finicky to set up because you're basically going to have to define a coordinate system and then manually enter some points. But you can, for example, read the data in and use Visual Preview, take note of the bounding box, and then put the numbers in there. I mentioned this yesterday as well, but a sort of related idea is the clip to initiator in the feature reader. This can help you improve performance if you're reading with initiator geometry. The additional clause or parameter, which I mentioned yesterday, which is very helpful, is the where clause, which you can use on some formats, reader feature types. And this lets you type in an SQL where clause to define which data is read. So in the example above, instead of using a tester to test for owner name begins with C, you could use a read from this table where owner name is like C with a percent sign. That isn't available on all formats, but it's definitely worth checking out in your workspace to see if you have the option to use that. And if you're able to restrict the data some way that way at the beginning, that will speed your workspace up. As I mentioned yesterday, it's also worth thinking about the use of SQL transformers here if you're worried about performance. SQL is generally going to be faster than reading an entire feature type with FME, particularly if you're doing things like filtering with a where clause, or if you're doing joins, particularly multiple joins, it can be quite a bit quicker to use an SQL transformer. Again, excess feature types, that's a problem. If you have feature types you're not using, use those. You can use the tools remove unattached to do that quickly. That will find objects that aren't attached anywhere. Those are all tips we sort of went over yesterday as well, but one that we didn't talk about is reader order. Some people aren't aware that the order of your readers and writers in the navigator does actually matter. Generally, writer order is actually more impactful on performance, but there are some cases where you should pay attention to reader order. One of those is if you're using a creator to trigger a transformer like a feature reader or HTTP caller or any other transformer that reads data, so maybe a connector transformer. You're generally going to want to make sure that you look at the create after readers option. That will let you choose whether this creator should trigger a read after all the readers are done or not. And that really just depends on where the work is happening in your workspace. If you're doing a lot of HTTP calls to get started, and then maybe later on you need some data from a reader, it's probably a good idea to make sure your creator kicks off first. Whereas if you have the other situation where you need to read a bunch of data and then make some HTTP calls based on it, you should probably use have create after readers be enabled. There are also occasionally timing issues in FME workspaces. These are kind of uncommon, and we generally suggest trying to design around them. So to avoid creating any kind of time conditions you're sort of skirting the idea of like creating a race condition in your workspace, though it's actually, I guess, closer to more of like a block on your performance, a bottleneck. And that happens mainly with group-based, well, only really with group-based transformers, which we also sometimes call blocking transformers for this reason. Group-based transformers, so any transformer that has a group by on it with the default settings, or any transformer that requires using groups. So for example, the statistics calculator. Any transformer that is group-based like that has to wait for all of its features to come in before it will send any features out. Most transformers don't work like that. Feature-based transformers, they process feature by feature. So one feature will come in, will be processed, and it will be sent along. And in fact, the pattern normally is a feature will travel from the reader all the way to the writer before anything else happens, unless it encounters a blocking transformer, and then the reader will send another feature. And it just works down the list of readers until everything is written out. So sometimes you'll run into a situation where you have a blocking transformer in a bad spot that's holding up the rest of the processing in the workspace. So we're going to look at that in a bit more detail when we talk about transformer performance. But the thing to kind of look out for is, do you have a blocking or group-based transformer that's waiting? It's stuck waiting for a reader ordered lower in the navigator. That's where you can run into some performance problems. And then very rarely, if you do have these kind of timing issues, you might want to have a look at the feature holder transformer, which lets you basically say stop features here until some condition is met. And that can be used to sort of, in a way, fix or address these timing issues. But generally, it's better if you can try to figure out a way to avoid creating them in the first place. So that's a little bit about reader performance. Why don't you go ahead and complete that quiz? And we'll continue on in a few moments. Let me know if you have any questions. Thanks.